Hi friends, today I am going to take the topic of CAD. So in CAD today I'll be telling only the basic introductions to the CAD. In that I'll be splitting it into two parts. First I'll tell you what are the basic idealizations in the CAD, and second I'll deal with the angle of projection. I'm not keeping the first video so long so that it's not too boring. So now let us start. What is CAD? Okay, CAD, that is computer aided engineering drawings. Here we have many types of drawing. We have natural drawings, geographical drawings, we have normal paintings, normal portraits drawing. Then the last drawings type of drawing is engineering drawings. In engineering drawings, basically we deal with the projections, okay? The projections. Now why this called computer aided engineering drawing? It's a simple reason. Earlier it was only engineering drawings because it was done manually on the sheets, but now we do it manually as well as in the system. And in the system it counts more for more marks for the printouts because everything is going to be digitalized in this era, so everything is digitalized. So this drawing has also become digitalized. So that is why it is computer aided. With the help of computer we are drawing the engineering drawings, the professional drawings. Now coming to the split up of this CAD, we have 6 topics as per the semester. The first topic is projection of points, then is projection of lines, projection of planes, projection of solids, development of surfaces, and the last is the isometric projection. This isometric projection is quite different from all these 5 topics. Now the first topic accounts for 5 marks, the second lines is for 10, planes 15, solids 20. That is a compulsory question in the question paper. The development of surfaces is for 15 marks. Isometric projection is for 5 marks. Now, when you look at these, when you learn these points, lines, planes, solids, you'll come to know that these chapters are very interlinked. And to understand this solid subject, we are learning points, lines, planes. They are also quite important, but they're slightly easier than solids. The videos of all these I'll be taking in the next part. Now in the exam you have choice between points, lines, planes. Either you have to attempt points, lines or planes. Then solids you have to compulsory attempt. Then you have choice between surfaces and projection. So it may differ according to the colleges and according to the semester syllabus, but this is the basic idea I have. Coming to the introduction of solids. Coming to the introduction of this CAD subject, these points, lines, planes, and solids are based on orthographic projection, whereas this development of surface is different from orthographic projection. Now, to have a basic idea of development of surfaces, if you consider this cover of a matchbox, okay. Now, if you cut it through this edge, this particular edge, which I've already cut, then you get 2 small rectangles and 2 large rectangles having same lengths. If you join it in the same way, the smaller rectangle, the larger rectangle, the smaller rectangle, and the larger, and then fix it at this point, then you get the cover of a matchbox. That is the basic idea of development. How you will develop the surface to form something. It can be cover, it can be frustum of a cone, it can be anything, and it has many more further topics in development, which we'll see later. For one thing to notice is that all dimension is in CAD subject is taken in millimeter. Never do it in centimeter. It's always millimeter. Coming to the size of sheets, because knowing the sheet is also important because the printouts are always taken on the sheets, and that is A4 wide. To have an idea of sheets, I am considering this particular piece of paper as the largest size, that is A0 size. The drawing sheets or the engineering drawing sheets, which you call it, which you have seen the civil engineers using. Now you fold it into half, you'll get the A1 size. Again fold it into half, you'll get the A2 size. Again fold it into half, you'll get the A3 size. Again fold this piece of paper into half, you'll get the A4 size. This A4 size is used in our CAD subject, and this particular way, this is the A4 wide, is used. Now when you do it this way, this is not A4 wide, this is A4 portrait. This is A4 wide, which you have to also do in the sheet setup in your software while doing in the system. So always remember it's A4 wide and it should be 297 into 210 millimeter. Okay. Moving to the types of arrows you use, because in engineering drawings you have projections, not other kind of portraits. So here we use arrows. We use three types of arrows. First is open arrow, a simple headed arrow we normally use in bulleting things. Closed blank arrow. Why it is called closed blank arrow? Because the head is closed and it's not filled. It's only a straight line and an arrow which is not filled from inside. Now, if it is filled from inside, then it is called closed filled arrow. And this is the most oftenly used arrow in our drawings. So, if you draw a straight line, draw this part of the line, this part of the arrow, the lower part of the arrow, and then you draw the head of the arrow, which should be always pointed. Then the size of the head should be in a ratio 3. This should be in a ratio 1:3. It means it should be, let it be 3x, and this head portion, this portion be 1x, and this should be 3x. So, and you have to fill it properly. So this is a closed fill arrow. Now, one thing to remember while drawing closed fill arrows is that your head should be always pointed, and you should not draw it like a very small, very vague kind of arrow like this or this. No, you should draw it perfectly. This should be small and this should be large, because you'll be drawing everywhere in your engineering field. So you should have a perfect arrow that should be pointed, and this head part should be longer. Okay, keep in mind, because as neat as your drawings will be and your arrows will be, then that neater your sketches will look, and that much marks you can get. Now, the types of lines we use in our drawings. There's thick line, that is continuous thick lines, thin line, continuous thin lines, curved lines, dotted lines, axis lines. You have to draw axis line like this. First a very big line, then a very small dash, big line, small dash, big line, small dash, big line. This is the axis line, how you draw the axis line. Then comes the dimension line, and the last line is leaders. I'll explain what these lines are and where they are used. So coming to the continuous thick lines, if you have a small object, okay, consider this square. If you are projecting this and you get an image of this square, so this square image is the real true image you are getting after projecting it. I'll tell you what is true image and what are apparent image later when you come to learn the chapter of planes. But for now, you consider whenever the thing is real, what you have obtained after applying all the conditions, that should be in thick lines, and the normal condition should be in very thin lines. So you can make out that this is the final drawing in the sheet when you take the printouts or do the sketches. That is continuous thick lines. Thin lines, while drawing any shape, you can use. Continuous curved lines are always used in developments. Basically, they are used in development because you have curved surfaces there after cutting the development portion. So it is not that much in use. Dotted lines. Dotted lines are very important because if you have to draw something which is imaginary, you indicate it with the help of dotted lines. Like if you have a cube, if you visualize it from the front, you can only see this part. Okay, this thing, you only see this thing when a cube is kept. But when you draw it like this way, then you can view this surface, and this surface. But how to represent this line? So that is an imaginary line because you can't visualize it or you can't see it from the front. So you draw it in a dotted way to show that that line exists and your drawing is also seen. So you can visualize this. You have a cube and the inside lines are dotted because they are there, but you can't see it from the front. So that is kind of imaginary, we call it CAD. We'll draw these kinds of lines when we come to the topic of planes. Planes are very important, planes and solids, so that with the help of the knowledge of the lines, it will be easier to know which part of the shape is imaginary and which part of the shape is thick line or thin lines. have a basic idea of this. No need to worry that much. Axis lines is anything can have an axis. If I draw a triangle, then that has an axis from all its apex. So that is a line which is passing through the center of gravity of anything. So axis lines, to represent axis lines are thin lines and they are represented like this. We'll use these kind of lines in solids and development. Then comes the dimension lines. Always in CAD, when we draw an object, if I draw this square, I have to mark its dimensions. So marking its dimensions, I'll mark in line which is double-headed arrow and write the measurement. Okay, let us consider it is 25. I hope you got it. This is the square and this is the dimension you have to mark. While marking the dimensions, you keep it in mind the distance between the diagram and this dimension line should be at least 1 centimeter or 10 millimeter. You know, that gives a very neat and nice looks to it, because if you mark it very close, or like if you mark it here, like this way I'm showing you, then it looks very clumsy. But when you do it perfectly in your grid sheets, mark it at a distance of 10 centimeter, then it looks neater and easily you can understand it, or any invigilator can understand it. So have your drawings always neat and arrows always pointed. The leaders, coming to the leaders, the last kind of lines, the leaders. These leaders are used to lead your path. Of course, leaders are there to lead the path. So how to use leaders? If I want to draw a square, I'll start from point A, I'll go to point B, C and D. So if I start from point A, I'll go to B, C, D and A. How will a person know where did I start from? So I'll draw the leaders. Leaders are only arrows you have to draw on the line. In the system also you get the toolbar for leaders. So these are the leaders. So if a person sees my drawing, they'll be able to know I started from point A and went to B, then C, then D and again to A. So leaders are the arrows which lead me to the way. So we use these leaders in everywhere, in every topics of our CAD subject. We'll see it further how we use. This is a basic idea of leaders. If I want to go from point A to point B, I'll draw like this. I'm going this way, so my leader will be like this. If I draw a circle, then my leaders will be like this, in this way. They'll be curved. Okay. These are the ideas for leaders. Now, I talked about orthographic projection. What is orthographic projection actually? So basically, orthographic projection is nothing but a parallel line projection. What is parallel line projection? So if I consider this eraser, okay, if I project a light, see, I get a shadow of it, a shadow in form of the bottom surface of this eraser. Now that shadow, if I draw that shadow, I'll get this eraser and the down surface as a rectangle. This rectangle will have the same dimension as that of the bottom surface, this bottom surface of the eraser. Now why I am getting the same size? Because the lines which I am projecting are just parallel from these corners. In a similar way, you can take a triangle. I'll tell you how the light rays works. If I project light which is parallel to this vertex C, A, B, C, vertex C, vertex B, if I join them, I'll get the same shape and this object of the same size as that of this triangle. I'll get the same triangle, the shadow of this triangle on the wall, on the paper, anywhere. So this is the image obtained. This can be a prism also, like square prism. So if it's a square prism and if you project it this way, the front face of that, you'll get a triangle on the wall. So what you are getting, you had a 3D image. I had an eraser, I projected the lines and it was a 3D object. But what I am getting is 2D. So what is orthographic projection? So you can define it. It's a parallel line projection where we obtain a 2D image of a 3D object, a way of representing 3D object in 2D plane. That is parallel line projection. In parallel line projection, because the light rays are parallel, the image will be always of the same size of that of the object. There will be no change. But when we go to the further chapters, we'll see because of the conditions given, the apparent shape comes. Apparent shape is the shape which is not of the same dimension of the object. If the object has a dimension of, consider, 3 into 4 millimeters, and after giving certain conditions to it, which I'll tell you how to give the condition, how it works, the new image obtained will not of the same size. Like if this is the 2 into 3 measurement rectangle, after giving the conditions, what I obtain is a rectangle of 1 into 2, then this is not of the same size. This particular thing is not of the same size of this rectangle. So this thing is called the true shape because it was truly given to us. And what we get after giving the conditions to the object is known as apparent shape. So basically in parallel line projection, we get the true shapes, having the basic idea what is orthogonal projections. So keep it in mind, parallel line projections are orthographic projections only, and it is a way of representing 3D diagrams in 2D way. Another thing to notice in the introduction is that what is the thickness of the lines in the system. So I told you there is the lines. Okay, what are the thickness of lines? What is thick line should be of measurement 0.5 millimeter. Thick lines, the thick lines. The axis line should be of 0.13 millimeter. These lines, these lines. This is a thick line. The points, in points you'll draw points that should be of 2 millimeter. The projector lines, what are projector lines? I'll tell you what are projector lines. You should remember that thickness should be 0.13 millimeter, and there is a XY line. I'll talk about XY line in the next video and tell the thickness that there only. Coming to the dimension lines, they're automatically set in the computer, but if you want to know, it will be around 0.13 millimeters. And the dotted lines are always thick lines. Remember, it should be thick. It should be thick. In the system, you get the option of thick, and it should have a measurement of 0.5 millimeter thickness. These are the basic thickness. Now summarizing what I have told is, first, the split up. I told you what are the important questions, how isometric projection is the way of representing 3D objects in a 3D way only. We don't get a 2D diagram here. If I have a sphere, then it will look like a sphere, and then there'll be a anything like a cone or something. When you draw it, you will get a perfect look of how a 3D thing looks. But in all these above 5 topics, leaving the development, that stands different from the orthographic projection. It's an interrelated part of all these topics. These topics they are based on orthographic projections. What is orthographic projection? This parallel line projection. Parallel line projection, if you have a project, you project the lines parallelly, and when you join the points, you get the image that is the true shape because it is of the same size of the object. So that image is 2D representation of this 3D object. So that is parallel line projection. Now what is true shape? If I have an object, the initial size of the object is the true shape, and when the given conditions are applied to it and what image we get after drawing it, that is the apparent shape of anything. Or if you have apparent line thickness, true line thickness. Okay, you have many things in that kind of possible ways are there. Now I told you about the different sizes of sheets. We are using A4 sheet here, which should be in wide. That is always in wide. It should be in 297 in 210 millimeter. All the dimensions should be in millimeter always. Keep in mind what kind of arrows we use. So it's open arrow, closed blank arrow, not filled but closed. Closed filled arrow, filled, but it is closed and filled, and it should have a ratio of 1:3. That means always remember, it's not at 1:3. You can draw it head, and the side part should be small and the head part should be longer comparatively. Okay, and should be sharp, thin, nice arrows. That gives you marks. And lines is thick lines. I told you where to use it. To draw the true last image, what we get is done in thick lines. It will be more clear when I teach the other topics. Continuous thin lines, normal drawing basic squares. Curved lines in development. Dotted lines to show the imaginary things. Axis lines to draw the axis. Dimension lines to mark the dimension. Leaders to show the path of the lines or the way you are doing. As I told you how to form the square and circle, how would I know if I mark the leaders? It is very important. If you draw leaders, perfect arrows, mark all the dimensions in your sketches, then you get 5 marks for that, and that accounts for the good marks too. So take care of the leaders, imaginary lines, and the thickness of the lines, which should be dark and which should be light. While coming to the planes topic, we'll understand what is thick lines and thin lines. Now I told you what are the dimensions of the lines as per the computer system. Thick line should be 0.5. Points which you draw should be 2 mm thick. Projector lines, I'll come to the projector lines later, but that should be 0.13 line. This x1, y1 and x1 line, I'll come to that in my next video. Thick lines, I told you, axis lines 0.3. Dimensions are automatically in the computer. These dimensions are automatically in the computer. Dotted line should be thick and it should be 0.5 mm. You have option in that toolbars in your solid edge software or any other software you use. So thank you guys. This was my introduction video. Next video is on the projection, angle of projection. So I hope you like it. Please do and subscribe it.